Welcome to BrewFix, where coffee meets craftsmanship. And one of the most fascinating yet overlooked truths in espresso brewing is that the first few seconds of a shot often determine the quality of the entire extraction. Because while many baristas focus on the total brew time or the final yield in the cup, the real chemistry and physics that shape flavor begin the moment water first meets the coffee puck. And those initial seconds set the stage for everything that follows. When the pump activates and pressurized water begins entering the puck, the water does not immediately flow evenly through the bed of coffee, but instead begins searching for pathways through thousands of microscopic gaps between particles. And during these first seconds, the puck either forms a stable resistant structure or begins developing tiny weaknesses that eventually turn into channels. And once channeling begins, the extraction chemistry becomes uneven because water takes the easiest routes through the coffee bed rather than dissolving compounds uniformly across the entire puck surface. This early phase of extraction is extremely sensitive to grind distribution, puck preparation, and particle size because the coffee bed must absorb water, swell slightly, and lock together into a uniform structure capable of distributing pressure evenly. And if the grind distribution contains too many fines or boulders, the water may rush through certain areas while bypassing others, meaning some parts of the puck over-extract while others remain under-extracted, producing espresso that tastes simultaneously bitter, sour, and hollow. The physics behind this process is closely related to permeability and resistance inside the puck, because espresso extraction depends on creating a balanced resistance that allows water to flow slowly and evenly while dissolving the desirable compounds from the coffee particles. But if that resistance structure forms unevenly in the first few seconds, the pump pressure amplifies the imbalance, turning tiny imperfections into major channels that dominate the rest of the extraction. Temperature also plays an important role in these early moments, because the first contact between hot water and coffee rapidly dissolves volatile acids and aromatic compounds that contribute brightness and complexity. And if the flow rate is too fast, those compounds may dominate the shot, while the later sweetness never fully develops. Whereas if the flow begins too slowly, the early acids may be suppressed, and the extraction shifts toward heavier, bitter compounds later in the shot. This is why experienced baristas often pay close attention to the first drops of espresso emerging from the portafilter, watching for visual clues such as how evenly the coffee begins to flow, how the crema forms, and whether the stream develops symmetrically across the basket. Because these early indicators reveal whether the puck has formed a stable extraction environment or whether channeling has already begun. The remarkable part is that once these patterns are established in the first few seconds, they are extremely difficult to correct during the rest of the shot because the water continues reinforcing the same pathways through the puck, which means the outcome of the espresso is often decided long before the cup is full. Understanding this principle shifts the focus of espresso preparation away from simply measuring time and yield toward controlling the early conditions of extraction through proper grinding, distribution, tamping, and machine stability. Because when those elements align, the first seconds of the shot create a balanced pressure field across the puck that allows the extraction window to unfold smoothly and produce espresso with clarity, sweetness, and body, which is exactly the kind of coffee engineering insight we explore here at BrewFix to help baristas, coffee enthusiasts, and technicians understand how machines, grinders, and extraction physics interact to shape the flavor of every shot.